Okay, so at this point, all the students in the class have picked either 0, 2, or 7, and they've evaluated this expression with those numbers. All right? So I'm here to show you of why we're going to do all this work. It's going to feel like a lot. It is. But you're going to see, hopefully, at the end of this, why we're going to do this. Okay? So the first thing I noticed about this expression is that this denominator, the far right one, is a quadratic trinomial. So let's try to factor it. What are two numbers that multiply to give you -6 and add to give you -5? Negative. Oh, I'm gonna go back to. Let me go. Oh, let me go back to black. X minus 6 and x plus 1. Now, when you write this down, if your brain hasn't seen it yet, take a look at the other denominators. The other denominators, I know, right, are pieces of this. Okay? So in order to add and subtract all of this, I'm thinking back to middle school. And in middle school, to add and subtract fractions, you need a common denominator. So my common denominator for this problem, believe it or not, is x minus 6 times x plus 1. So what I'm going to do is I'm going to multiply this first expression times x minus 6 over x minus 6. The reason is, if I multiply these in the bottom, all right, if you look at these two in the bottom, now this looks like this denominator. Okay, now watch what I do to the middle one. Watch what I'm going to do to the middle one. The middle expression has the x minus 6, so it doesn't need an x minus 6. Which one does this one need to look like this denominator? X plus 1. So I'm going to multiply the top and the bottom by x plus 1. So if I do that, then all three expressions have the same denominator, x minus 6 times x plus 1. Okay? Let's see if you can follow along with me. So what I do now is I'm going to write a big fraction bar. In the bottom, I'm going to put my common denominator, x minus 6 and x plus 1. The order does not matter, Camilla, because you're already thinking it. The order does not matter. Okay? Now, look at my first expression. It was just a number 1 in the numerator. But now that 1 needs to multiply by x minus 6. So what am I going to write here in the numerator? X minus 6. Very good, right? Because 1 times anything is itself. Okay? Now, look at the next term. The next term had an x in the numerator. But it needs to multiply by x plus 1. So what am I going to write for that one? Plus 1x. Very good. Now be careful here. It gets a little tricky. Yes, Avi, a question. Where did I get x minus 6? Right here? This x minus 6? No, the one that we added. This one. Blue or red? Good. Yes, colors. No, the one at the bottom. Not a color. The black one. This one. Okay, so this, Aviana, is the common denominator. Right? So do you see how when I factor this denominator, I got these two factors? So what I'm doing, Aviana, is I'm trying to get every single one of these denominators to be this. And so that's why I wrote it here in the bottom, because if they're all the same, then I don't need to write 3 of them. I just write 1. The one at the top, this one, oh, my bad. 1 times x is x. 1 times negative 6 is negative 6. My fault. Okay. All I'm doing is touching the tops. I'm not doing anything to the bottoms. Because the bottoms is all the bottoms are the same. All the denominators are this. All right, now the last one. This is where be careful. Do you see how I'm not doing anything to the last expression? Okay, but students, when they do this, they'll put the 5x minus 2 and they'll just write it. But what is the symbol here? Subtraction. So you have to do subtraction for both of them. So what's minus a positive 5x? Negative 5x. What's minus a negative 2? Plus 2. Good job. I'm sorry? She's speaking another language. Sounded like English. Okay. Now, I'm going to combine like terms. I'm going to combine like terms. That's what is up. Okay? I do know what. So the x squared is going to be in the numerator. Okay? Now, look at the x. I just took this x squared and moved it over because it has nothing else in common, Alonzo. Now, look at x plus x is 2x, and 2x minus 5x is negative 3x. No, it should be negative 3x. Right? One was a positive, one was a negative, right? And then negative 6 plus 2, negative 4. And that's over my denominator, which is still x minus 6 times x plus 1. Okay, you did it, but you didn't. You're not done. We did it, but we're not done. There's more. Wait, there's more. Now, do you see in the numerator? Everybody look at the numerator. Focus on the numerator, the top. Do you see how that is? Not me, the top. That's a quadratic trinomial. That's a quadratic trinomial. You should always try to factor it. So can you think of two numbers that multiply to give you negative 4 and add to give you negative 3? Negative 4 and positive 1. I think that's what I heard somewhere. Frank. And wait, hold up. I'm holding myself up. I mean, I guess that's gravity. Do you see the x plus 1s? They're gone. All right, and now for the fun part. Okay? Raise your hand if you chose 0 for your number. Raise your hand if you chose 0. Anthony, of course. I'm not going to go with you because you got an error message. You didn't do it right. Let's go with Kylie. Did you do it right? What did you get for 0? 2 over 3. Did everybody get 2/3 that did 0? Okay. So if you type in 0, you now get 0 minus 4, which is negative 4. If you type in 0 on the bottom, you get 0 minus 6, which is negative 6. And if you divide and reduce, you get 2/3. How many of you chose 2? Julio, what'd you get for 2? You should have gotten 1/2, 1 over 2. So watch what happens when I plug in 2. 2 minus 4 is negative 2. And 2 minus 6 is negative 4. Negative divided by negative is a positive. Reduce, you get 1/2. The last one, who chose 7? You already did 0. Stop. Only 2 students. Okay, Alonzo, what'd you get for 7? 3. Let's see. 7 minus 4. Okay. 7 minus 6 is 1. And Alonzo, what's 3 divided by 1? It's 3. Now, the whole goal of this activity, exercise, was to see that did it take you very long to type in your numbers? Did it take you that long? Some of us longer. Right? But for the most part, it didn't take us that long. If you hit clear before you finish, yes, that takes longer. But for the most part, it didn't take you more than like 30 seconds. Okay? But now, if I ask you to plug in 100 numbers into this one, as opposed to 100 numbers into this one, I think you're all going to choose that one. So it was a lot more work, right? But now we have set up any time we want to move forward with this expression to be much more efficient. Okay, so that's why this, what we're going to do, is in your math curriculum. Okay, and that's why it was a thing many years ago. Yes?
What we just did here, was it just like a warm-up, or was it like, we don't do that?
The way that it is what we're going to do. What it's in math, in the teaching style that I use, it's called to give you a headache. Right? Give you a headache, and then this is the medicine. That's what I'm trying to do. So I'm trying, Nada, for you to see the reason why we're going to do this. That's my goal. Yes, I'm trying to make you think, like, oh, I don't want to do that anymore. I want to do all this work, even though it's a lot of work, because now it'll be much easier to plug numbers in. That's the whole goal. Okay? Yes, Evian. It didn't matter what number you chose, because you should have written down your answer, but then I used those same numbers to do it much faster. And did I need a calculator? No. So I can just do it much faster. Okay? All right. Now, let me show you. I'm sorry. Alondra?
But I don't get it because we still have to do the big one to get to the little one.
We're going to combine them into one expression. So instead of having 3 different expressions, yes, we did a lot of work. I'm not going to tell you it wasn't a lot of work. It absolutely was a lot of work. But once we finish it, now we have a simple expression that we can use going forward.
So say the question for that one problem was asking a little bit more instead of having to plug in back into a big.
You can use, you got it. That's the whole point, right? And so students ask me every year that we do this, Alondra, and are you ever going to need this? No, but in whatever job you do, you will be given a lot more money for your job if you can do your job more efficiently, and that's what this is. Okay. Everyone look at example 1. We're going to do this in 30 seconds. Yes, right now. Here we go. No. Okay. The reason I want to go through this one really fast is because on the SAT and on my test, these don't happen. But I wanted to show you because when you take math in college, it might happen in college. Okay? So you'll notice in this example, it's subtraction. And what do you notice about the denominators? They're the same. It's not dots, right? It's not the difference. But they are the same, Josue. They're not going to cancel out. But what this means, Nada, is because they have the same denominator, I can go right away and subtract the numerator. All right? Here we go. 3x minus 6x. Very good. Negative 4 minus 1. Negative 5. And you did it.
That's the answer?
It took 20 seconds.
This sounds like 10 seconds.
Student, great. Now, that's not going to be on our test. It will not be on the SAT. Okay? It could be in college. So there you go. Now you've seen it. Now let's do something that's more challenging. Yeah, I'm hoping you see that this is really straightforward when they have a common denominator. All right. Let's go to example 2. Oh, man. They don't have the same denominator. Okay? So remember, write small. Write small. Okay. When you look at the first denominator, x plus 2, I cannot factor x plus 2. But I heard Kylie already say about the second one. X squared minus 4 is the difference of 2 squares. So this one is going to be x plus 2 times x minus 2. So to get a common denominator, I am going to need to make this x plus 2 become all of this. So which one does it need? It is already a plus. It needs minus. So I'm going to write in the top and the bottom times x minus 2. Okay? So now if I do that and do the multiplying in the numerator, I will have the same denominator. That means I am allowed to add these together. All right? Now I'm going to show a little bit more work than I did on the last one. All right? So make sure your brain understands. So I'm going to rewrite this x plus 2 down here, but what is also going to be in that new denominator? Very good. Again, Camilla, the order doesn't matter. In the numerator, you have x minus 2 times x. So what is x times x? X squared. And then negative 2 times x? Negative 2x. Now, this is what's really, when I was in high school, it really kind of blew my mind, was my teacher said, if you look at this expression, okay, what you just wrote, and you look at the original expression, so that one right there, x over x plus 2, they're the same. This one right here and this one right there are the same. All right? This one, we've beefed it up because we want to add it to this one over here. Okay, Anthony? Right, so I said beef up. Was that funny? What should I say next class? Bulk up? I need help here. You're not giving me any feedback. You're just giggling. What is it? Loosen up. But I want to make it seem like there's more going on. So loosen up doesn't really help. Tighten up, but tight means usually like kind of smaller. Wait, steroids? I don't want to go that direction. Forget I asked. Okay. Does everyone see how now we can add these? Fill it up? Okay. I don't understand, but that's fine. Oh, okay. Got it. All right. So, what I've done, okay? What I've done is I've added the numerators. Now you'll notice that in the numerators, there were no like terms, right? X squared minus 2x and the negative 8 are not like terms. So I just put them all together. So again, we are done. But we're not done. Because if you look at the numerator, we should try to factor. So what are factors of negative 8 that add to negative 2? Negative 4 and positive 2. All right, so what am I going to cross out? The x plus 2's. So you're going to get x minus 4 over x minus 2. Now, that is our answer, but if you just put this on the test, you won't get full credit.
It says identify any x value.
Identify the values that would make it undefined. So, careful, it's all about the denominator, right, Alondra? So actually go back here, bless you. What would make the denominator 0? 2 and negative 2. So how I write it, right, because you guys know I'm a mathematician, x cannot be equal to plus or minus 2. Of course, you could write x cannot be equal to 2, comma, negative 2. So, just trying to be more efficient, right? Camilla. Yes, always look for the denominator, because we're trying to say, Camilla, is you cannot divide by 0. If you divide by 0, bad things happen. So that's why we write this. Like, hey, everyone out there, plug in any number you want to this, but don't plug in these, bad things will happen. Shh. Yep. Okay, so 8 and negative 10. But make sure you write not equal. Every year I get kids that write x equals, and I have to take off points because this one. All right, let me do one more thing before I send you to your spots. Sad, it's going to be a long 3 months. All right, what I want to do is I want to look at number 1 on the exit ticket. So I want everyone to rewrite number 1 on the exit ticket, rewrite it halfway through the slide. Just right here, 2x plus 1 over x minus 2 plus x minus 3 over x plus 1. So just rewrite it. Now, the reason I want you to do this one, all right, we're going to talk about it, is because if you are taking the regular version of my test next week, you have to be able to do a question like this. Okay? So that's the vast majority of students in here, so let's go over this one first, and we'll talk about the ones you're going to try. Okay, what do you notice about these denominators?
They're not the same.
They're not the same, and they cannot be factored. All right, so actually, if they have nothing in common, the LCD is the two of them multiplied together. All right, I'm sorry? Cool, so if you want to get a common denominator, you need to multiply this first expression by what? Very good. In the top and the bottom. Now, I say that every time, but am I actually going to be doing any multiplying in the bottom? No. Now, what about for the one on the right, the second expression? Times x minus 2. Okay? So that means our answer our answer is going to have x plus 1 times x minus 2 in the denominator. And I'm going to finish this problem for everyone at 12:55. So that means from now until 12:55, we're going to try some problems at our spots. So everyone go back to your board slide. All right, so look to the one on your left. This is the order I want you to try these problems. 1, 4, 2, and then 3. If you are doing regular in this class, you have to be able to do 1 and 4. If you are doing honors, you have to be able to do 1, 4, 2, and 3. Okay? So if you're doing regular, I expect you to do 1 and 4 before 12:55. If you're in honors, all 4 before 12:55. All right? 2, 3.